Friends, in this video, I'm going to show you something quite special. No need for a script to be written in our software for conducting confirmatory factor analysis, path analysis, and structural equation modeling. Isn't it wonderful? So we'll be seeing how to conduct this all using the LAVAN, that is latent variable analysis graphical user interface, GUI, via RStudio. You just need to load a package of lavaangui, install this package in RStudio, and you'll get an interface where you can build in a model just like you do in for IBM SPSS AMOS. So since AMOS is a licensed software, you are not having the access to that. Don't worry, it's a completely free software, RStudio, which you can install and you can directly use Lavan graphical user interface even if you don't have any knowledge on writing a script to execute your data analysis. So let us start. But before diving into the analysis, let me show you some of the important metrics which are involved in assessing the confirmatory factor analysis, that is measurement model assessment, and path analysis and structural equation modeling. So you see, we have comparative fit index and Tucker-Lewis index, both of which are incremental fit indexes. A good value which is desirable over here is greater than 0.95, greater than 0.95. And if it is not 0.95, at least it should be 0.90, greater than 0.90 in both the cases. For RMSEA, that is root mean square error of approximation, and standardized root mean square residual, both of which are absolute fit indexes, the recommended value is less than 0.08, less than 0.06, and less than 0.08 for SRMR. These are the references for the content we will be covering today. So this is an article on lavaangui by Professor Karsh of 2025, published in Structural Equation Modeling, a multidisciplinary journal. And here is the reference for these indices, the thresholds, fit indexes, which I told you, by Hu and Bentler 1999. So this is the cutoff criteria for fit indexes in covariance structure analysis. Now let me remind you one thing over here, that we are doing covariance based structural equation modeling, not variance based structural equation modeling. Covariance based structural equation modeling, which we actually do in AMOS. So that is actually used for testing a theory, not for prediction. For prediction, we go into variance based structural equation modeling, wherein you use a software like SmartPLS, or you have a free option, that is Adanco. So we'll cover that in future videos as well. So this is restricted to covariance based structural equation modeling in case you don't have the access to IBM SPSS AMOS. Now let us dive into the software and see how to install and how to use this thing. So here in my RStudio, you see here I've already installed via this command install.packages lavaangui graphical user interface. Once it is installed, I go to library lavaangui and I run this, load this using this command lavaangui round bracket closed. And then it says loading required package shiny, and automatically it shifts me to a window which looks like this. So I get a window like this. You have the grid options over here. Here I have clicked on show grid. If you cancel it, you get a blank canvas. So if I click on show grid, you get something like this. Now, on the right hand side, you'll see the different commands and what action will be taken if you press these commands. So you can go through it and read it in a while to understand it better. Now, the first thing which we want to learn in any model is importing the data. So how to import the data? Let us first go to file and load model or load data. If you have a pre-specified model which has already been drawn over here and you have saved that model, you want to execute that model again without the need to draw that model once over again, you can simply go and load that model if it is saved on your computer. Otherwise, you want to make a new model, you first need to import the data, load data. So I go to load data and I have this data customer satisfaction CSV form. In CSV, I have a data of 305 people. So you see here, it's a data of 305 respondents, wherein I have case ID, occupation, gender, and 4 indicators marked on Likert 5-point scale for food quality, 4 for service quality, 4 for ambience, 4 for price fairness, and 4 for customer satisfaction, which is the endogenous variable. But we do not make a distinction on the basis of endogenous or exogenous variable when we are conducting confirmatory factor analysis. In case you are doing a path analysis, then we don't take these indicator scores, rather we take their composite scores. So here are the composite scores which have been calculated. So you can take the composite scores if you want to do a path analysis instead of confirmatory factor analysis. In confirmatory factor analysis, we are basically checking that whether these indicators are appropriate for measuring the latent variable, that is food quality in this case, service quality in this case, ambience in this case, and price fairness and customer satisfaction. So this is your data which has been loaded. Now let us close this data and see how to make the model. So you see all the things over here populated over here on the top bar. Now you just go to factor, take, drag it on the sheet, and it will ask you what indicators, reflective indicators are there for this factor. So first one is food quality. Let me select FQ1, press the shift button and click on FQ4. Press on OK. You got this. See how easy it is to generate this latent variable of food quality. You want to rename it, just right click, rename variable, and I'll name it as F quality without any spaces, right? Like this. Similarly, I'll do for another one, another factor like this, and this is service quality. So I just check on SQ1 and press the shift button, SQ4. Okay, I got it for service quality. Let me name it to service quality. So very easily you can draw in that model just like you do it in AMOS. So similarly, we'll do it for the other three also. There are five latent variables in our study. So I have created all five latent variables with their indicators: food quality, service quality, ambience, price, fairness, and customer satisfaction, where this customer satisfaction happens to be our endogenous, that is dependent variable, but we do not make any distinction. Once again, I repeat, for conducting confirmatory factor analysis. One thing more good about this lavaangui is that you'll get the syntax simultaneously generated for the graphical model which you create over here on the canvas. On the right hand side, you'll get this syntax which you can copy and paste and run it in R software as well. So no need to learn how to write this, but you can directly take it and execute further analysis in R, which are out of the scope of Lavan graphical user interface. So you get a script written over here which is ready made and you can use it. Just copy it and take it to R to be used. Now, what next has to be done? I need to align them properly. So I just go to apply layout and recommended tree to, you see automatically they have been aligned by using apply layout recommended tree to. So this is the design which I have chosen. Now I have to draw the covariances. Select this double headed arrow and draw the covariances like this between all. So every latent variable should be linked to the other latent variable, right? Like this. Now this one with this and this one with this, right? This one with this. So all of them have been linked now. Covariances have been created, right? So you can check the covariances over here on the right side, whether you have missed on any or not. You'll be able to see all of them over here, right? You see all of them are linked to each other in this table, that is covariances, right? Now what next? Now I want this to be a little clean so that I can visualize. Just select it and it will become purple in color. Just a left click, a single left click will make it purple in color and you just drag it like this and you'll be able to see clearly all these paths. Fixing the parameter of one of the indicators of each latent variable, which we have to do compulsorily in AMOS as well. So here it can be done automatically. You just see I am going to press on auto completed model. You have the first indicator of each latent variable. The parameter is fixed to 1. You can manually do it also by right clicking it and fixing the parameter like this, and you enter a value 1 and you can do it, but no need to do it manually when you have the function of generating it automatically using this auto completed model function, right? Now we are ready to run this model and check whether this gives us a reliable result in terms of these indicators representing their latent variables or latent variables attributing to the desired amount of variance in the indicators. That's how we say it in statistical terms, right? So now I just need to press on estimates, and you get the results instantly. See, so easy, right? So estimator use was maximum likelihood, which is recommended in this case, which we actually use in AMOS as well. ML is maximum likelihood. You can always change the estimation method from here. See, you have got different estimation methods over here, right? Missing values list-wise deletion is adopted in this case. In case you have missing values and you don't want to lose on data, then you select full information maximum likelihood. In my case, the data is 305 respondents and there are no missing values. So I've checked on list-wise deletion, right? So these are the two options over here which you can use. Then it says number of observation 305, and this is the chi-square goodness of fit. This has to be statistically insignificant, ideally more than 0.05, right? But it is quite sensitive to sample size. So often, most of the times you'll get a p-value which is significant, right? So don't worry about this. That is the reason we go in for other things to check on our model fit. We go on to check on CFI, TLI, RMCA, and SRMR values, right? Now we check on user model CFI. It's 0.896. The recommended is above 0.90. TLI also above 0.90 is recommended. So this is a low value, right? What to do with this, I'll tell you in a while. How to improve your model, right? And then we don't have to see archaic and Bayesian criteria. This is done in case we want to compare the models, right? Then we have RMSEA. RMSEA is 0.090. It has to be ideally less than 0.09, and SRMR less than 0.08, which is okay in this case. It is 0.06. So only SRMR is okay. What about rest of them? I need to check on modification indices, and I'll show you where can you see the model parameters also, that is standardized values also, factor loadings also, right? So I go to more results, and here you see parameter estimates standardized. So these are the factor loadings. You see here, these are the factor loadings. Food quality FQ1, 2, 3, 4. So factor loadings are well above zero point 0.7 in this case. Only FQ4 is 0.5. So sometimes researchers use a threshold of zero point 0.5, zero point 0.6 or zero point 0.7, which is very good, excellent. So depending on your study, whether you want to exclude this indicator, say FQ4 from your study, or you want to keep it, you will have to justify that why you want to remove it or why you want to keep it in case it has a low factor loading. So in this case, it's above zero point 0.5. So many of the times it's seen that above zero point 0.5 people do keep it. In service quality, you have four indicators. These are the factor loading. You see all above zero point 0.6. Ambience, the factor loadings, all above zero point 0.6 again. Price fairness, the factor loadings again above zero point 0.6 you see here. And customer satisfaction, one is 0.59. So all of them are above zero point 0.5. Now, what to do about the model fit which we saw about CFI, TLI, RMSEA, which were not giving us the desired numbers which we require to go ahead with the structural model assessment. For now, we are doing the measurement model assessment, which is done using confirmatory factor analysis, right? So now I can go to factor scores. This will just show you the table of values of your data and their factor scores. So you see the factor scores over here. Then modification indices. So modification indices help us to improve the model. So how to check this? We have to check on the highest modification index value. So if you come to MI, double click it, you see customer satisfaction 1 indicator with customer satisfaction 2. Modification indices is 100.722. That means if we connect CS1 with CS2, that is co-vary these two indicators, there will be a reduction of 100.7228 in our chi-square value. How to do this? CS1 and CS2, how to co-vary these terms? So I'll just show you. You go back and here is your data. So this is the user model. So in user model, I just take this double-headed arrow and CS1 and CS2. You see here, these is CS1 and CS2. I covariate it. Now let us see the estimates, whether any difference has been caused or not. You see here, we got the results and the chi-square test statistic is reduced. It has become 452 now. CFI is 0.923. It has improved. It is above zero point 0.9 now. TLI is above zero point 0.9. It is 0.908. And what about RMSEA? RMSEA has gone below 0.08. It has become 0.078. Further, if we want to improve it, see SRMR is also improved. It is 0.053. Right? Furthermore, if you want to improve this model, then I can go with again modification indices and check on the next highest modification index. So in this case, if I double click, you see here SQ1, SQ2 35.1757. So no need, because I have already achieved a model fit which says that SRMR values, incremental fit values and absolute fit values are well within the thresholds required for a confirmatory factor analysis, and I can go ahead with the structural model assessment. So now when we want to convert this measurement model into structural model, we need to remove the covariances that are linked to the dependent variable, the endogenous variable customer satisfaction. How to remove them, and then we have to put the single-headed arrows pointing from each of the independent variables to the dependent variable, as in this case we are assuming that these four independent variables are affecting the dependent variable customer satisfaction. This is a case of multiple linear regression. So how to do this? But we are doing it in context to structural equation modeling, where all the relationships will be estimated at one go. So that is the difference between multiple linear regression and structural equation modeling. So let us see how to remove these paths leading to dependent variable, the covariance paths. I just click on it and press delete edge like this. You see, I press on this, it becomes purple, and I click delete edge, right? Again, I do a left click, right click, delete edge, left click, right click, delete edge. Now you see these dotted lines. Don't worry about them. Once we put in this single-headed arrows and we run the estimates, this will go forever. And we are there to assess the structural model, right? Now we have the single-headed arrow and we say food quality affects customer satisfaction, service quality affects customer satisfaction, ambience affects customer satisfaction, and price fairness affects customer satisfaction. Now, you see, those dotted lines have gone, and now this is a structural equation modeling. Now we can go to apply layout and select recommended tree. So you see here, the model has changed, and now you can easily see that customer satisfaction is being affected by food quality, service quality, ambience, and price fairness, right? And these are the four indicators of customer satisfaction: CS1, CS2, CS3, and CS4. So for doing the bootstrapping of structural path coefficients, I go to estimation, standard error, number of bootstrap sample 1000 is mentioned over here. Prescribed is 5000, but for the sake of this demonstration, we'll keep it 1000. So when I run number of bootstraps 1000 and click on estimates, so bootstrapping is happening, you see here. We just checked on the bootstrapping and I'm showing you the bootstrap result with 1000 samples, which will help us to assess whether the path coefficients are significant or not in this case. Got the results you see here, and bootstrapping has completed its work. Now let us check whether these path coefficients are significant or not based upon the bootstrap results. So go to more results, and here are the parameter estimates, standardized measures we are looking at, and then we have to look at, see, price fairness to customer satisfaction, service quality to customer satisfaction, food quality to customer satisfaction, and ambience to customer satisfaction, right? So now let us see the lower and upper bound confidence intervals being generated after bootstrap. If there's a zero falling in between, as you see in this case, minus 0.0711, and 0.25. 0 falls in between. That means it is insignificant. The relationship is insignificant as told to us by p-value also, as told to us by z-score also, because z-score has to be either lesser than minus 1.96 or greater than plus 1.96. So out of the range of minus 1.96 to plus 1.96, then it means that yes, it is significant. P-value has to be less than 0.05, which is not in this case. Then service quality, again insignificant. Food quality to customer satisfaction, it is on the borderline, you see 0.0525. But if we see the bootstrap result, which are more reliable, we see 0 comes in between. That means it is insignificant, right? We go with the bootstrap results, right? Then ambience to customer satisfaction, this is the only thing which is significant in this case, as p-value is less than 0.05, as you can spot in by looking at a confidence interval lower and upper limit also. There's no 0 falling in between. That means it is significant. You see here. So that is how you assess the structural model relationships using the Lavan graphical user interface via RStudio. I hope the session was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Till then, thanks a lot.